Did life start on Earth? Or did it start somewhere else and get delivered to Earth somehow, kickstarting the process of evolution towards this lush green wonderland that we have today? Well, almost 10 years ago, NASA launched a rocket with a mission to try and answer that exact question. This was something that they'd never attempted before. They wanted to bring back a sample from an asteroid that's been around since before the sun existed. But why? Why would an asteroid from outer space that's been around for billions of years give us any insight into how life formed here on Earth? And what were they expecting to find? Well, today I'm diving deep into the story of the Bennu asteroid and giving you all the context that you need to understand what's happening here. Why is this such an important accomplishment? How do the fields of chemical biology or the study of life or even the search for aliens relate to this? If you support this kind of independent research where I'm just obsessing over things that I think are super cool and that more people should know more about, and then breaking them down into these kind of explainer videos so that you can understand what's going on without needing to do all that work, subscribe to my channel to get more content like this. If you really want to support me, you can sign up for my Substack, where I give in-depth reviews of the sources that I use for the videos and insights into the processes of creating and running this channel. And let me know in the comments what you want to know more about. I'd love to hear from you and kind of build a community here where we're all learning about things that we think are cool. So, as a disclaimer, I'm not a rocket scientist or an astronomer or anything like that, so some of this isn't exactly in my wheelhouse, and if I get anything wrong, please correct me. However, I do have a pretty good grasp on the chemistry and the biology that I'll be mentioning today, but I know that, I don't know everything, and I'm probably wrong about some of that stuff too. I don't think anybody knows everything. So don't take this as an absolute truth. Just know this is kind of my own research that I was doing, my own interpretation of the things that I've read up on. So here's the story as much as I understand it. Basically, there are some pretty good theories about the origin of life nowadays. This is because if you put together very basic ingredients like carbamate, carbon dioxide, and ammonia, if you put those all together, they can react with each other just through random interactions, and they actually tend to form the basic building blocks of life, such as the bases for DNA and RNA, or sugars or amino acids. Now, at the same time, scientists have found these same building blocks, these DNA pairs, sugars, amino acids, inside of meteorites, which are asteroids that have fallen down to Earth. So that's kind of weird. Like, why are we seeing that on the surface of something that was in outer space? And because some of these asteroids were formed billions and billions of years ago before, the whole solar system really took form, maybe this means that these basic building blocks are scattered all over our solar system, or maybe even all over our universe, and they're not unique to Earth. But then you've got this problem where these meteorites, they're on the surface of Earth, they're dirty, they've been contaminated. And, they came screaming down through the atmosphere in a burning blaze, and now they've been sitting in dirt and getting crawled on by bacteria and other life forms for years and years. Even if we get to a meteorite the instant that it lands, it's still been burned up and contaminated with our atmosphere and soil. We have no way to know for certain whether those building blocks are actually from outer space or whether there's some sort of contamination that we're seeing with the meteorite. And that's the question that this NASA mission set out to address. They wanted to collect a sample of an asteroid that is not a part of the Earth to see if these building blocks of life are on that sample. And why would this be important? Why does it matter? Well, if these ingredients for life aren't unique to Earth and they're instead scattered throughout our solar system, that might mean that life developed on Earth simply because it was the right environment. It's warm and it's wet and there's the right materials. If there are base pairs for DNA and sugars and amino acids on these asteroids in space, then it might mean that the story of life and the origin of these materials actually started long before the Earth came along. And if this managed to, be throughout the whole solar system and then take root here on Earth, it might be able to do the same in any other situation that's got the right warm, wet, and wild environment. And low-key, I think this makes a ton of sense. I mean, think about it. What is the more probable outcome? Option one, you've got that Earth is just this exceptionally unique, one and only planet where these specific chemicals of life existed at just the right time and in the right conditions. Or option 2, these chemicals of life, they were floating all around in the early days of the solar system. They could have proliferated on any planet given the right environment, and they proliferated on Earth because it had the right environment. To me, it feels more likely that it's the second one. Earth is, of course, incredibly unique. Don't get me wrong, we're one in a freaking bajillion, but I don't know if we're one of one. If there's another planet that has similar conditions to us, and that's almost a certainty if we have a near infinite universe, and actually 100% certain if the universe is infinite, I wouldn't be surprised if life developed on a planet with the same conditions as here on Earth, if these building blocks are kind of all over. Anyway, I get a little sidetracked, so let's get back to this NASA mission. I think that's just freaking insane. I mean, think about what they're doing with this mission. Like, let it really soak in. NASA, they're sending a rocket into space, which I think is already super, super cool. I mean, we can go to space. I think we kind of take this for granted. It's only been a thing for like 50 years that we can go into space. Okay, 70 years almost, right? That's insane. So they're going into space. They're going to an asteroid. They're taking a sample from the surface and then they're flying back to Earth, delivering the sample. I mean, if you think about it, they're sending a robot to collect a sample from an asteroid. That's like we're living in the future. I think that's crazy. If you're hyped up about this stuff like I am, and you kind of feel the same way about these types of scientific advancements, and you want to support my dream of becoming an independent researcher and communicating these topics, subscribe to this channel. If you really want to support me, check the description for a link to my Substack, where I'll go over these sources in detail and talk about the process of starting and running this channel. So, about the specifics of the mission. It was called OSIRIS-REx, which is short for Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer. That's a mouthful. I like OSIRIS-REx better. I think that sounds way cool. The purpose of this mission was to go to this asteroid Bennu, collect a sample, and deliver it back to Earth. Simple enough, right? So when I read about this, one of my first questions was, well, why that asteroid? Why Bennu? Which, as it turns out, is actually one of the first links on the NASA website for this mission. I guess they get that question a lot, and I'm not very original, but if you want, you can actually visit this exact web page. I'll have it linked down below, and you can check out all these resources that they have. It's super well organized and smooth. They're doing a great job at making this science accessible. So they say there's a couple reasons that they chose this asteroid. First, it's old as hell. It's super old. It's literally like older than the Earth. It formed during the early days of the solar system when the Earth wasn't even really formed yet. And this is important because the Earth itself has been beat to hell by weather and tectonic plates moving and asteroids running into us, that we can't really tell what the solar system was like at the very beginning looking at Earth. But this asteroid has just kind of been chilling in space the whole time and hasn't had all those factors, so it can tell us a lot about what the conditions were like back then. Second, they've been able to look at this asteroid using kind of magic, essentially, to determine that there are organic compounds like carbon and clay on this asteroid. I say it's essentially magic, but it's just a really cool tool where you can look at the wavelengths of light bouncing off of the asteroid. And they use some cool math and tools to determine that the asteroid is essentially the color of carbon and the color of clay. So they can say, oh, there's carbon and clay there. That makes it, it could be relevant, like to life. Third, they chose this asteroid because it's really close. Most asteroids are all the way out by Jupiter in an asteroid belt, but Bennu is kind of chilling in between Earth and Mars. It actually comes pretty close to Earth. And this makes it a really good candidate because we can get there faster and easier. You don't have to go all the way out and back. And on a side note, I was wondering this, and they mentioned this on their website, so I guess a lot of other people wonder about this as well, but the asteroid Bennu, it's not going to hit Earth during our lifetimes, but there is a less than 0.1% chance that it hits Earth between 2150 and 2300. So you're probably fine unless you're watching this video in 200 years, in which case, look out. So, at this point, if this story was a movie, there would be some dramatic clash where the satellite almost gets destroyed in space, where the sample goes hurtling into the unknown forever before our hero comes in and grabs it at the last second and brings it back to Earth. but in real life, it wasn't as climactic. While we do have this crazy video of how they collected the sample where they just slammed the satellite into the asteroid, essentially, they just kind of completed the mission. Collected the sample, they flew it back to Earth, and then they landed in Utah and they picked it up, and now they've been doing all these sorts of tests on it. So they landed in September 2023, and they've been sending it out to different labs, and people have been publishing their findings on these samples. So if you stuck around this long, here's where we get into these kind of exciting results. And now that I've given all this context of the mission, I can talk about what they actually found in the samples. Ever since they got this sample back and have been distributing pieces to researchers, finding after finding has been coming out. Some of the most exciting findings of all actually came out just a few weeks ago, and here's my understanding of the main gist of things. Basically, they found exactly what they were hoping to find and more. Remember when I said that we didn't know if the building blocks of life found in meteorites have been there since the meteorites' formation or not, or whether they are contamination from the Earth? These samples from Bennu blew that skepticism out of the water, because not only did this uncontaminated sample have all the bases for RNA and DNA as well as some amino acids, but it was the first time ever that scientists found the sugars needed to form RNA, ribose sugars, in an extraterrestrial sample. They had found it in meteorites before, but they had never found it in an extraterrestrial sample before. And this is a huge deal. I'm going to get to why in just a second, but first, what else did they find? They found salts that were formed in a particular way that might only be formed by the slow evaporation of salt water, which means that these reactions to create these precursors to life might have happened in some sort of saltwater environment containing these minerals. They also found a gum-like substance. This is a polymer with a bunch of nitrogens and oxygens, and they think that this might have provided the chemical precursors needed to trigger the development of life on Earth. Although this one, I'm going to be honest, I don't understand it as well. So, all of this is super important for a couple of reasons, and the one that sticks out to me as a chemical biologist in training a little bit was the discovery of ribose. So why is this so cool? Well, first, ribose is what makes up the backbone of RNA, hence the name ribonucleic acid. What's really interesting, though, is that they didn't find deoxyribose, which is the backbone of DNA. And this might lend some credence to the idea that RNA evolved first, and then DNA came after RNA as a way to store information long-term for the RNA. That would be pretty critical for kind of the central dogma, or maybe our interpretation of the order in which things evolved, and it lines up with a lot of the theories that chemical biologists have been probing at for a while. Now, second, these findings provide even more evidence for the theory that the precursors for life didn't originate on Earth, but were rather delivered by asteroids crashing into Earth, carrying these base pairs, amino acids, and ribose sugars, and delivering them into the right environment for them to evolve into what we know of as life. Now, do these findings mean that there are aliens on Mars, or that there's definitely extraterrestrial life out there? No, unfortunately not. They make it very abundantly clear that this is not confirmation of life on the asteroid or anywhere else. This is not the discovery of alien life. Just that these very much not alive molecules that happen to be the precursors for life, as we believe, were on this asteroid. And so it's kind of fun to be like, oh my God, this confirms aliens. And believe me, I really want it to be aliens. I love the idea of having knowledge that we aren't alone. But this is not that. It does mean that because these precursors were formed at the early stages of the solar system, they could have been formed at early stages of other solar systems as well. And that might open the window for finding evidence of similar life based on these building blocks on another planet someday. I really hope I live to see that day. I don't know if I will, but I really hope so. It is still cool as hell, though. I mean, come on. We are flying into space to collect asteroids that we are examining with techniques that are so cool that I kind of think of them as magic, all to learn that the precursors for our entire concept of life exist outside of the Earth. That's an insane sentence, and I'm so blessed that I get to say something like that. Quite literally awesome in every sense of the word. I really, really love getting to learn these things and be in a time when such amazing things are going on. And none of this can happen if we don't fund research. We are only getting to see these incredible things because scientists have spent their entire lives working towards small, incremental changes in their fields, and now we're reaping the rewards of this generations of work before us, people who saw the value in doing this type of research. It is truly incredible what we can accomplish when we fund research on these long timescales. So, let's wrap it up. What did we cover today? Basically, we opened up a 4.5 billion year old time capsule from before the sun and Earth existed, and we found that there were precursor elements for life inside, or on the surface. What does this mean? Lots of things. It might mean that life could have evolved on other planets and we might find that one day, or it could mean that RNA came before DNA in the evolution of life. If you stuck around to the end of the video, make sure to subscribe. If you like this kind of independently led scientific research and find these types of topics as fascinating as I do, subscribe to my Substack. Right now, this is the absolute best way to support me in my dream of doing this full time. Thanks for watching, and I'll see you in the next one.